Hey YouTube, Joshua here with Tipsy Python, your casual guide to learning how to program with Python. I'm back with another video, and in today's video we got a couple goals. First off, I want to demonstrate how to use key value pairs and how to implement them in Python and JSON. And then using that knowledge, we're going to go back and refactor the whiskey rating app that we started in the last video. In today's video, I'm actually going to be sipping on Jameson Black Label. I've never had this one before, so I'm really excited to try it. I got my poker right here. I usually keep this thing in case them Java fanboys come around, but today we're just opening whiskey with it. Maybe it's just because it's the 375, but it's a pretty nondescript bottle. I did go on the website for this one, and they said that it's called Black Barrel because they double char the barrel before aging the whiskey. And just kind of on the first couple nosings here, I do smell a lot more char than I do on the standard Jameson bottling, so I'm a little excited to get sipping on this one. Not bad at all, but I'm going to wait till the end of the video to give you my real thoughts there. Let's get into the code first. Get your drinks ready, get your computers ready. I'm going straight into Jupyter. Let's get into it. Now you might remember this guy from an earlier video. I'm talking about the dictionary data type. The dictionary data type is a common Python object that's a key value data store. Now key value pairs are really hot, and with good reason. They make programming and object reference very easy. There's a lot of implementations of it. To illustrate, let's just get into the code. To initialize a dictionary, there is a function that we can use. I'm going to say whiskey dict equals dict, and when we print this object, we'll see that we have a dictionary. You may remember back to the list function, which kind of does the same thing. I like to cut straight to the chase, and when I initialize one, I just use the curly brace notation. Let's actually get into some key value implementation. My dictionary is empty right now. I'm going to set a key named name equal to the value Joshua, and when I print this object, you'll see that it's no longer empty. Now that seems simple enough, right? But the thing is that dictionary makes life even easier because of the way that you can reference the objects that are held in them. Let's take a look here. If I want to get the value out, all I have to do is call my object, use the bracket notation, and then reference the key name. And because this is a collection data type, it can hold multiple key value pairs. I'm going to set another key named favorite, and the value, just to fit today, is going to be Jameson. If we use that bracket notation with an integer like we would to reference the index in a list, we're going to get an error. To illustrate what you might see, if I try to reference 0 position of a dictionary, I'm going to get a key error. That is unless we actually have a key value pair in which the key is named 0. Now let's go over a few common methods you'll see when working with dictionaries. One is the get method. It accepts key name as an argument. And at first take on this one, you may think that's kind of silly. It's the same exact functionality as the bracket notation, but it actually does add something nice here for you. In the event that I try to reference a key that doesn't exist, I'm going to get a key error. If I do the same thing using the get method, it does an error, and we'll see that it actually returns a none. Another good method to have in your back pocket is called setdefault. It accepts a key name, but also accepts a default value name. In the event that the key is present in the dictionary, it does return the value, but if it doesn't, it returns the default that we provide. And not only does it return the default, it actually sets the value in the dictionary for us. One more common method that you're going to see is named update. The update method does what it sounds like, and it updates the dictionary, but actually accepts a dictionary the values that it uses to update. One other note on the formatting here, it can accept keyword arguments that look something like this. And hey, I got nothing against the update method. I do use it, but most of the time I opt for the bracket notation just to set a value quickly to the key that I want. There is one use case where this really shines though, and that's if you have to update multiple keys and values in the same statement. I can say, instead of passing dictionary here, I can define my dictionary, then pass it in, and we'll see that all of these keys and values have been updated in my original dictionary. I'm enjoying this more than I thought I would so far. This one's for the dictionaries. Now, as you might have guessed by now, there's some common operations that we perform on dictionaries. Being that it's a collection object, a lot of them have to do with looping through the dictionary and getting each key out of it, getting each value out of it, or getting both the key and value item as a pair. Don't sweat it, these are all written up for us as some pretty convenient methods. The first one we're going to observe is the keys method that returns a list of the keys out of my dictionary. Along with that, there's also a values method that returns the values. And many times we're working with the pairs, so we want to get both out in the form of tuples. Items is one that I reach for a lot. You can implement it very simply in a loop like this for key value, because I need to unpack the tuple that it returns. For key value in whiskeydick.items, I'm just going to say key is and value is, and we're just going to put our temporary variable names in there. And just like we add items, sometimes we have the need to remove items from a dictionary. One way that we can do it, very similarly to a list, is we can use the pop method and then reference the key name that we want to remove. And in the event that we ever wanted to clear a dictionary altogether, we can use the clear method. Now, dictionaries are super powerful because they're a way to associate data. We can create some really expansive data trees using dictionaries. And by implementing our data store like this, we're going to have something that's much easier to navigate than perhaps a collection like a list. Let's illustrate this with an example though. Suppose that we have a collection of books and authors, and we're holding these books in a list. We may do something like a list that contains tuples holding a book name and the author. It would look something like this. Now, there's nothing wrong with this approach, but if we wanted to find out something simple about our data, like who wrote Moby Dick, we would have to take an approach like this. For book in book collection, if book 0 equals Moby Dick, and print book 1. Now again, nothing wrong with this approach. It does work, but in order to figure out something from the list, we have to iterate through it to find the item that we want. Like we said earlier about dictionaries, they are indexed, but not by a position numeric index. They're indexed by key, so we can look up our results much faster. If I implemented the same data store as a dictionary, it may look something like this. I have a book collection that's a dictionary. I have book titles as keys. And then as values, I have nested dictionary, which I have containing the title again, but also any associated metadata about each book. And with this method, our retrieval logic is so much simpler. It looks like this. Print book collection, and I reference the key that I'm interested in, Moby Dick, and then the key I want the value of, author. Now, isn't that elegant? That's much easier than iterating through a list. And for this reason, key value data stores are very, very popular, not just in Python, but in many other coding languages. And one of the problems that we hit as software developers is that oftentimes we'll have processes written in different languages, and perhaps we need to port this Python dictionary into a Java hash map that implements similar logic. I can't just pick up my Python object and transfer it into another coding language, but we could find some sort of interface that implements key value pairs and do it that way. And one very popular implementation of this is called JSON. I'm actually going to look on w3schools.com to view about it. JSON is JavaScript object notation. It's a lightweight format for storing and transporting data. And when we look at it, ooh, now that looks familiar. As a matter of fact, it looks so familiar that I can pick up this JSON object. Again, this isn't a Python site. I'm looking at JSON. I can pick up the JSON object and dump it directly into Python, and it works. That's not to say that they're the same though, so let's keep reading. It has some syntax rules that are very strict, but the highlights here is that JSON format is actually text only, and that the code for reading and generating JSON can be written in any programming language. What this is saying is that there's actually a text format for implementing key value pairs that's shared across many different programming languages. Let's look at how to use it with Python. Thankfully, like most things in Python, it's not very difficult. There is a standard library module I need to import called JSON. I'm going to set a variable to store my JSON object called book.json. I'm going to say JSON, use the dumps method, and it accepts a dictionary data type. So I'm actually going to use the book collection that we've been using so far. And when I print book.json, it looks very, very familiar, but there's one important thing to note here. It's no longer a dictionary. This is actually a string of text. Now let's work this from the other end of the equation. Suppose that I get some text from a server. Now all this is a string that's formatted according to this JSON specification. Just to verify that, I'm going to use type. Now to get my data out of the string and into a dictionary, I'm going to set a variable equals JSON. This time I'm going to use the loads method, and it takes the string data as an argument. Now I have a dictionary, and I can reference the data using this bracket notation that we've been doing. If there were any main ideas that I want you to retain from this video, it's that 1, dictionaries are cool, use them when you can, and 2, that it's easy to go back and forth between string JSON and a dictionary object. Now, we're not pulling data from a server just yet, but there are many opportunities to implement the dictionary data type. As our exercise for today, let's go back to that whiskey ratings app that we started in the last video. Instead of storing a bunch of lines of text, let's store a JSON object that we can turn into a dictionary and then easily reference the values inside of our app. I still have our application saved right here. Now, one more thing that I'm going to do is I'm going to actually open up our data file, and I'm going to clear out the content that we have in there and just initialize an empty JSON object. To start the refactor in my app, the first thing I'm going to do is read in the dictionary from the very beginning, even before the user makes any actions. I'm going to start by grabbing this line of code. So the app is going to start, open our file in read mode. We'll read in the text with the read method. Then I'll import JSON module and use it to turn this string into a dictionary. Now refactoring the rest of the code, if the user selects right, we're still going to prompt them for some data, but this time I'm going to form a dictionary that holds the results. Then I'll assign it to the review dictionary. I'm going to use the name of the whiskey itself as the key in the dictionary, and the value will be this nested dictionary that holds the whiskey metadata. Now that the dictionary is complete with the information we need, we just need to write it as text. This time I'm going to opt to rewrite the whole file, and we're going to write json.dumps. That means dump our dictionary object to text, and the dictionary as the argument here. Let's run it and make sure this works. I'm going to write a review. Whiskey name is Makers. I give it a 7, and my notes are peanuts. The prompt indicates the review's been saved, and let's just check our data file. Okay, perfect. This is the kind of thing that makes our life easier. No more playing around with new line characters, no more playing around with concatenation, no more playing around with delimiters. We're storing our app's data to a file in a format that's very easy to read and write and that we don't have to manipulate very much. Getting back to our app's refactor, let's go with the read option. Now, being that we already read this object into memory, it's being held in review dictionary, we don't need to do a read here anymore. So I'm going to go straight to our iteration for key value in review dictionary.items. Now we can also bypass all of this logic. And we know the whiskey name is the key itself. The rating is part of the value, which is a dictionary. Key is rating, and the same with notes. And when I was highlighting just now, I did notice there are some tab characters in here. I'm going to fix that real quick. That makes me feel better. One last formatting thing here. Because I'm using single quotes to reference my dictionary keys, I'm going to use double quotes to reference my formatted string. Now let's check the actual application, make sure everything's still working. First, I'm going to read reviews. I'm going to write another one. Weller Antique. Give it a 9. Hot. And all the reviews are read out. We have identical functionality to the first version of the app, but I think you would agree, the logic is a lot simpler now. And one of the nuances they don't talk about much when it comes to programming is that when it comes to code, simplicity is maintainability. And speaking of maintainability, I don't know how I'm maintaining my composure sipping on such a good whiskey. Talking about this whiskey a little bit, the nose on it is surprising me. It's actually a little bit more both aggressive in terms of being punchy, but also sweeter than the standard offering. I can only imagine this has to do with like the caramelized sugars coming out of the wood when it's double charred. But surprisingly enjoyable so far. Let's give it a taste. There's definitely a resemblance to the base offering Jameson in this one. I mean, there's still that foundation of like earthy, grainy cereal at the bottom of it. Working our way up the flavor stack, I think there's like a little bit of grass clippings kind of flavor in there. And the regular Jameson is sweet, but I think this one's actually a little bit sweeter. I get like both white and brown sugar as well as caramel. And the finish on this one doesn't linger, but it's very enjoyable. I get a tiny little puff of smoke just to say that you're done. I don't specifically remember what the price difference was between this one and the base Jameson, but it's very enjoyable. Given the two, I'm not turning my nose up at the regular Jameson green bottle, but given the choice, I would opt for the Jameson Black Barrel. I do wish that this one was proofed up a little bit more. It's still 40%. I think if this was like 90, maybe 92, we could have something really special on our hands. And that's all for today's video, friends. Again, if you enjoy this type of content, please consider subscribing to my channel. If you're interested in seeing the notes from Jupiter that I took for today, I'll be posting them on my GitHub in the description below. And until next time, friends, Tipsy Python.